Please join me in welcoming Tony Lambert.
Thank you. All right. So this talk kind of started off with a nebulous, sort of cloudy mission from one of the managers at Red Canary, Joe Moles. If you've ever met Joe, he has this propensity to talk with his hands waving all the time. When he talks at a full tilt, he looks like a windmill. And when he talked to us, he said, hey, we have a lot of people asking about Linux coverage. We want to expand things. We want to make things better. And as we did more research, we started looking at what public research existed. And there's not a whole lot of public research, except for like a few very notable instances where people talk about their data server Linux systems being breached. Everybody and their brother has an IoT device that's been breached, however. And we can kind of glean some things from that. So we really dove into figuring out some of the payloads that bad guys use, some of the tools that are used, and how to do process monitoring around this. So a little bit about me. My name's Tony. I work at Red Canary. Most of my day job is finding out what bad guys use, how they use it, and how to detect it. Recovering systems admin, I used to work in the higher ed and state government sort of area, so it was interesting. And it's an entirely different environment than Red Canary is, and I love the change. I used to teach on the side, and I still love to teach. That's why I'm here doing this. This is also kind of why I'm attracted to threat intelligence, because when you start looking at intelligence, it's lifelong education just by another name. When you really think about it, it's like when we have intelligence-driven security, it just means we're educating ourselves before we defend. So I wanted to start off talking a little bit about what an actual alertable technique is. We deal a lot with alerts in various parts of our lives. Alerts aren't necessarily just something that happens with security products. They happen with your smoke detector at home. They happen in all sorts of areas of your life. You may have a car alarm, something like that. And I want to kind of show what the difference is between an alert from your security product and an alert in your daily life, and how we can kind of draw some of that context from the daily life that lets you immediately know something is wrong and put it in your security products. Figure out how to make your alerts not suck. We want to cover a little bit of decision criteria. How do you make a good alert? If you want to go at it from a systematic, repeatable process, how can you kind of grade some of these things? There's no matrices involved with this. There's no spreadsheets, so it's significantly less structured than some of the previous talks, but we're going to talk a little bit about it anecdotally. And we're going to cover some actual hard, fast, to the weeds, like analytics that we have actually implemented in our organization that have been relatively high fidelity for us, some that haven't, and some that absolutely sucked when we tried them out. Hopefully this is going to help you a little bit. This is stuff that's been derived from adversary payloads, raw data. It's something that's not necessarily from a synthesized report. This is stuff that is seen in the wild. To start off, we have to define what an alert is. At its core, an alert is going to be some sort of notification that an abnormal condition has occurred in the environment. If you have a car alarm, it means somebody's breaking in. If you have a smoke detector, this means there's smoke somewhere in the house. Something is going on that you don't want to go on, and you need to fix it really quickly. The idea behind an alert, though, is for you to understand what's going on and act, you have to have some greater context. You have to know why the alert has fired. You have to know what condition that alert is telling you about, and you need to know how to act afterwards. So, for example, with a smoke detector, the context for this alert, there is smoke in your bedroom. You need to get out fast. If you had security products that gave you that kind of immediacy, that kind of context, and we've all had those smoke detectors that go off and there's no smoke, stuff like that. False positives, but the more you can kind of provide that context in, the happier your analysts are going to be. With anything, your alerts require care and feeding. We try to look at alerts as kind of a diagnostic process of something that is going wrong in your environment. When you go to the doctor, some of your care requires some care and feeding. You may have an individualized care plan for you. This is going to be the same thing with your alerting. This is going to be the same thing with your security program. Any security program that you implement is going to be a little bit different from your friends. The best security program is one you can stick to. It's like an exercise plan. So as long as you can keep with it, as long as you can keep tuning, you're going to get better at this. What does the alert workflow look like? Most of the time we have a condition has occurred and the alert will fire soon afterwards. Just because the condition has occurred doesn't necessarily guarantee the alert will fire. This is a really good thing to focus on when you look at sensor placement. You know, if a fire happens in a house and there's no smoke detector, there's no alert. It's the same thing in your network or on your endpoints. If an activity happens on an endpoint or across a network and there's no sensor, you won't get an alert. So to move on down the workflow, we have to have a sensor. Somewhere between 2 and 3, if the alert fires, defender investigates, your analyst comes in for the day, they check their email and Outlook, they grab their coffee, and then finally they dial in and they start looking at their high priority alerts in a SIM. And eventually, the alert has to go somewhere. There's an escalate or there's a hide. Your escalation may be to a threat intelligence team, your escalation may be to an incident response team. That alert has to go somewhere or else it's dropped in a bottomless hole. If you want to hide things, you have to document false positives. And every time you have a hide, you should learn something new about your organization. We talk a lot about threat hunting, that there's no such thing as an unsuccessful hunt, because every time you hunt, you learn something new, and you should have documentation. The same thing should be true with your alerts. Every time you have a false positive alert, it doesn't mean that it was an unsuccessful alert, it just means you know something new. There are some problems with alerts, and I have to say, my wife helped me proofread my slides, and she's a wonderful person, and she panicked when she saw this picture, because she's not used to having more than like 10 unread emails in her inbox at a time. If you buy a security product, most of the time if you leave it at its defaults, there's a lot of context missing. When you buy something from security vendor X has no idea what's going on in your environment. You may have a special snowflake product that is only in the auto industry. You may have something in the Department of Energy that has never seen the light of day anywhere else. So that may cause tons and tons of false positives. Vendors will err on high volume by default because they don't want you to miss something. They just tell you everything. For you to make things better, you have to give a little bit of context. You have to show analysts why it's important, what to do afterwards, and provide guidance for this escalation process. So as we set down the path of trying to make alerts better, we have to take some time to do a systematic process of what actually makes an alert better. What do we qualify as a good alert? Theoretically, we want an alert to take very little time to investigate. We want that alert to have enough context that that analyst can come up, have that alert right in front of their face. They can say, all right, thing number 1, thing number 2, thing number 3 has happened. We don't have to do a lot of investigation. We can just follow back to the origin and then mark up all this information, give it to our incident responders, and they can go towards remediation. The quicker they can do that investigation process, the better the alert is going to be. You can go on to more alerts afterwards, or take a break afterwards. We want alerts to be fairly significant in terms of abnormality. We don't want an alert that says, hey, somebody has logged off of a Windows computer somewhere at like 5 o'clock. That's an alert. It's not a significant alert. It's what the less significance alert do is it trains your personnel to ignore alerts. That's not something that you want to do. How would you feel every time you cook dinner and your smoke detector goes off? Sooner or later, you're going to learn to ignore the smoke detector and there's a real fire in the house. It's the same thing with security alerts. We want to have a slow time or a low time to respond for any sort of alerts. We want things to be quick to investigate and quick to remediate. The more information you can have in this alert to lead your incident response, to inform your remediation, the better it's going to be, the happier your IR team is going to be, the happier your analysts are going to be. Everybody's just happy. It's a win all around. So we wanted to take a look at some alerts for the Linux side that don't suck. They've worked really well for us. Tell you about the ones that didn't work well on towards the end. All of these have been, like I said, derived from real-life adversary tools. My wife has been actually kind of entertained by me snake handling payloads at home, like figuring out what bad guys use and looking at the malware. So it's been an interesting experience with this. The first one I wanted to touch is time stomping. If you're not familiar with time stomping, this is going to be a practice of changing timestamps on a system to hide adversary activity. This happens in opportunistic attacks. This happens in targeted attacks. Anywhere that a bad guy can drop a file, they're going to want to try to shield that it's there or slow defenders down in forensic analysis. Most commonly in some of these opportunistic scripts, we see the touch command. If you're not familiar with the Linux side, touch will be used to modify timestamps or create empty files. Most of the time, we'll see touch with the ACMR command line flags. What this does is it's a change access time, creation time, modification time, and we're using a reference file. We're taking the timestamps from one file and planting it over on another. We have to think of what's the bad guy's intent with this. They want to make whatever file they're time stomping look like it was there at the time of installation alongside bin.sh. Most of the time when we see timestamps being modified, this is going to be something from an installation, something from normal system management. Most of the time with normal system management, you're not going to see all of the timestamps being modified at the same time, and you're probably not going to see all the timestamps modified at the same time from timestamps of a file that has already been originally installed on the system. This is going to be something that is really suspicious right off the bat. It gives your analysts some quick investigation time. They can look for what issued this command. They can look for the origin of the file that's being time-stomped. They immediately have 2 investigative leads that they can run to ground. And you've also informed your IR team, we definitely know that this file is probably going to be evil. We're going to have to get rid of it. And they get a head start on things. The next one is diving a little bit into process injection. This is notoriously kind of weird on the Windows side. It's still just as weird on the Linux side. Some of the techniques are a little bit odd to spot, like ptrace, some of those. For the one we're covering here, we're going to cover process injection using LD preload. If you haven't floated around Unix circles for a while, LD preload was this wonderful functionality from the glibc library that lets you specify a shared object library, the Linux equivalent of a DLL, and inject that DLL into any process that is running for a particular user context. So let's imagine that you have an SSH process. You want your adversary's library that steals credentials to load into this process. You want to have, you want PS to not return back malicious processes whenever you get started investigating things. You can preload a malicious library into these processes to manipulate output, steal credentials, do something else. So most of the time this happens on the user side, but it can happen at the system level. If you have tools in your environment that lets you audit command line flags, or that especially at the environment variable level, this is going to be really awesome if you can look for LD preload in your specified environment variables. There are very few times that you're probably going to be using this in your environment. The only time that I've seen in our data set where it's being used legitimately is for folks that are using very specific monitoring software. And if you're using that monitoring software, you're probably going to know. Your systems admins are going to know this is going to be a documented exception. The thing that is much less common is going to be modification of this LDSO preload file. This lets you define preloads for the entire system that the root user will execute a process and it'll preload in. Your Apache user may specify a process and that preload comes in. You end up defining something that gets preloaded for the entire system. The really cool thing about this is it's really quick to respond to. You can delete the LDSO preload file without harming the rest of your system. Most of the time, if you have one of those monitoring solutions, you may not want to do that. You can typically unset, undefine your environment variable, and it'll help clean this up very quickly. And you can go and tackle whatever library has been specified inside that variable. It's very quick to respond to. The really cool thing, this is used by rootkits. This is used by like user space rootkits to hide activity all the time, hide network connections, hide process activity. By doing just a little bit of quick deletion, unset environment variables, you can undo the functionality of a rootkit that may be hiding processes and go after the real threat on your system. And the final one for the ones that don't suck, I want to talk a little bit about masquerading. Masquerading, we talk a lot more about on the Windows side because every process likes to hide as SVC host. On the Linux side, we see some of the same things. If you dissect some of the opportunistic crypto mining, resource hijacking scripts from the past, you'll see a lot of process names that look like kworker.ds, kthread.ds,kthrottle, kaudit, things like this. These are intended to confuse defenders and make them think that they're looking at a kernel thread. When you're looking at a Linux system, when you do PS and look for all the processes, chances are you've seen some weird looking processes that start with K and have brackets around them. And those are processes that correspond with kernel threads. They don't have binary images that back them on disk. They don't have a path. They don't have a valid MD5 hash, things like that. So whenever you do see a process named kworker, whenever you do see one that's named after a kernel thread or has the name of a kernel thread inside it, and it's represented in something that has a path, especially temporary directory, this is going to be something that is immediately suspicious, immediately should fire an alert and investigate for your crew. This is going to be quick to investigate. You just find what has dropped that file. You find, if you have the right tooling, you can go back and figure out what processes executed around that time, what files were dropped around that time, and run it to ground from there. You may have noticed a trend so far. Which tactic have all of these analytics fallen into? Yeah, I heard evasion. All right. So defense evasion. We've typically seen with various public research and payloads that attackers will follow kind of a specific methodology. They'll compromise a web app, they'll compromise a database, something that is a public-facing application, use curl or wget to pull down a payload and then execute that payload immediately afterwards. In Windows land, we call this living off the land because they're using built-in tools to the operating system to download and operate their exploits. With any sort of living off the land opportunity for an adversary, we have to assume that their capabilities are the same as your system's admins. We have to assume that they're the same as your desktop admins. What is going to be the telling difference here is that we have to figure out what the adversary's intent is. The most functional analytics for us have been the ones that show intent. Masquerading shows really clear intent. There is no reason a kernel thread should be living in a temporary directory. This is definitely going to be evil, and we can track it down a lot better. We're going to see this trend continue on. Here are the analytics that we can kind of make work. They start off a little bit noisy, but as you tune them in your environment, they're going to get a lot better. Remote file copy, this is going to be where an attacker tries to download and execute their tools. Most of the time, using a curl command going to paste bin is going to be evil. If you have a business case where this is legitimate in your environment, please contact me. I want to know. And we can work it out from there. We can find if there's a better way. And typically, so that is probably going to lead to a high fidelity alert. What is less high fidelity is going to be something like curl or wget reaching out to a random IP address to download a Mirai variant or some other tool that is going to infect an IoT system. What you'll have to do is you'll have to figure out what IP addresses, what scopes are usually talked to by your systems, and then start alerting on the things that are outside those scopes. So if you look for wget and an IP address that's outside your scope of management, that's something that can turn into a high fidelity alert depending on your environment. If you manage a large IP space, I'm very sorry. That's going to get rough. The next one is going to be remote services for lateral movement. This is an actual example of what I believe Rock or another threat actor that's done opportunistic cryptocurrency resource hijacking, what they do to try to move laterally on a system. If you've ever done key-based authentication and configuration for Linux systems or Unix systems, you'll typically see that there's an authorized users file, an authorized host file, and there's going to be all of your good key stuff that goes with it. What these opportunistic scripts will do is they'll parse that authorized host file and try to contact every host that you've contacted in that authorized file and try to issue a curl command like curl a pastebin.com in the payload and funnel that script into a bash shell or sh shell, something like that. This is going to be a little bit more high fidelity depending on the site that's being used. We found that sometimes, however, this matches up with an application deployment pattern. If you deploy Docker in your environment, if you deploy some cloud stuff in your environment, some installers, depending on how you use them, might match this pattern. You just have to tune those out. And now, this is the Hall of Shame. Anything discovery is going to suck. And mostly it's because operating system noise. When you log on to a system in Linux and it has the little prompt that says you're logged into this host with this username, how do you think that all gets generated? Recon commands. And if you're going to alert on recon commands or any sort of combination of recon commands, it's going to be really rough on you. What works best for us is looking for some sort of cluster of activity where we can say, okay, there's maybe a little bit of recon or a little bit of user recon, a little bit of network recon, a little bit of, what users are on a system. When it occurs in a cluster like this, chances are you're more likely to find somebody that is enumerating a system looking for privilege exploitation vulnerabilities. It's not going to be something that's alertable on. This is going to be something that you're examining logs or examining a report after the fact. The use of sudo. It's admin's favorite, helps you make sandwiches, helps you do all the things that admins don't want you to do. This is going to make long investigations with very little return. You're going to have very long rabbit holes that your analysts run down and get nothing out of it because you're going to flag on every time your system's admin is trying to do something on a Linux system. It's going to make the admins mad, going to make the analysts mad, going to make the managers mad, and everybody's just going to have a bad day. If you really have to look at sudo alerting in your environment, do it in an audit, do it in a report, something where it's not a continuous monitoring effort. I have to make one caveat with this. When I made these slides, I did not account for the edge case vulnerability from a couple of weeks ago with sudo with a -1 username and all that mess. That one's a high fidelity alert. Get that one in, but otherwise it's better for reporting and audits. The final one, I have to include this because we did have somebody ask about it. If you're not familiar with Unix and Linux land, RM and RF means delete all files recursively and force the deletion. Root is obviously the equivalent of C drive from Windows over on the Linux system. And theoretically, this is going to delete everything on the system, and it's going to do it very quickly. When somebody approached us with a question about this analytic and says, can you guys detect on this? We said, well, we can write an analytic for it, but it relies on you basically winning a race. And so what about winning this race? And you have to rely on your sensor making it back to the server that this RMRF command has arrived before the RMRF has messed up your sensor. You're not going to win the race 95% of the time. Especially, we're in the land of SSDs now and really high-speed Xeon processors. So you're just not going to win it most of the time. If you do win it, again, let me know. I want to see how this comes out. And I would additionally argue that if you ever see this alert, if you ever have this alert and you actually get a hit on it, the bad guys probably didn't get a successful execution because most of the time on modern Linux systems, you also have to include a flag that says no preserve root because modern Linux systems said, hey, we need to put some guardrails on this sucker before people start blowing things up. And that's one of the good things about it. Most of the time, your help desk is going to know that something has gone wrong with this system before you know if somebody has wiped it. It's just something that happens. And hopefully there will be evidence for you to figure out what happened when you get there. So, kind of close up, we've got a little bit, 5 minutes left. Alert where you can, where possible. The first ones, alert on as much of those as you can. Report and hunt, do cluster analysis where you can otherwise. I wanted to additionally share some resources that I thought were awesome. The most successful organizations we've talked to so far that haven't been using some sort of process monitoring commercial tool have been using some form of OS query, AutoD, combinations thereof, trying to figure it out in their environment. If you want to learn about AutoD and you want to be able to implement some attack-style analytics for AutoD, both of these resources are really awesome to do that. Be Fuzzy, I'm not sure what your real name is, but thank you, dude. And Florian Roth has a really good AutoD project. Both of them have some really high fidelity alerts in there. Some of them won't, or some of the alerts won't be high fidelity. So just use what you can and improve the rest.